Our today's topic is Introduction to Software Engineering. At first, we should know what is software engineering. Actually, software engineering is a very important thing, and the software developer should follow the software engineering technique. If they want to writing a good quality programs in a cost effective and efficient way. So we can say that software engineering is a systematic and cost effective technique to software development. And this technique actually develop through the first experience, and there are different innovations and lessons the software developer learns from the first mistakes. And any software developer who wants to develop a software, they should follow the proper rules of software engineering. If they follow the software engineering rule, they will be success to develop that software. So we can say that software engineering is an engineering approach to develop a software. And this software engineering is actually these rules actually develop through some knowledge, and this knowledge forms the foundations of the software engineering principle. So what is this knowledge? This knowledge actually the all past programming experiences and innovations for writing good quality programs, and that program should be finished within a time period, and it should be cost effective, and the programs should be efficient to solve the problems. So we can say that this is the engineering approach to develop a software. So why it is the engineering approach? Actually, there is an analogy. So what is that analogy? Suppose you have asked to a contractor to build a small house for you, and that contractors are not really experts in house building. So then what they will happen? They normally carry out minor repair works only, and may at most undertake very small building work, such as the constructions of boundary walls. And now, if they faced with the task of building a complete house, then what the contractor can do? So the contractor would draw upon all the knowledge he has regarding house building, but he would often be left with no clue regarding what to do. He might not knew the optimal proportions in which cement and sand should be mixed to realize sufficient strength for supporting the roof. In such situations, what will happen? So in that situations, he would have to fall back upon his intuitions. He would normally succeed in his work if the house you asked him to construct is sufficiently small. The house constructed by him may not look as good as one constructed by a professional, may lack proper planning, and display several defects and imperfections. So it may even cost more and take longer to build. So this is the case for a contractor who don't have a proper knowledge, is a layman, he don't have a proper knowledge about how to build a house. Now, suppose you just hire a contractor to build a large 50-storied commercial complex, and in that case he might be agree, and he might be ambitious and agree to undertake the task. In that case, if the contractor is not much more professional, then what will happen? Then he will be failed. He is sure to fail, and the failure maybe comes in several forms. The building might collapse during the construction stage itself due to his ignorance of the theories concerning the strength of materials. The constructions might get unduly delayed since he may not prepare proper estimations and detailed plans regarding the types of quantities of raw materials required and the time which these are required. So these are the scenario may happen. So to be successful in constructing a building of large magnitude, one needs to through understanding of civil and architectural engineering techniques such as analysis, estimation, prototyping, planning, designing and testing. Similar things happen in case of software development projects. For sufficiently small size problem, one might proceed according to one's intuition and may be succeed. Through the solutions may have several imperfections, cost more, take longer to complete, but failure is almost certain if one undertakes a large-scale software development work without a sound understanding of the software engineering principles. So we can say that software engineering is an engineering approach to develop our software. I hope students will understand why software engineering is very much important to develop our software. Now we will discuss why software engineering is neither a form of science nor an art. Actually, a software engineering discipline is not classified either as a form of science or an art. There exist several fundamental issues that set software engineering apart from both of science and art. Here we will discuss some of these important issues. So the first issue is it is an engineering discipline where the software engineering makes heavy use of past experience. And this past experience is systematically arranged and theoretically basis for them provided wherever it is possible. And whenever no reasonable theoretical justifications could be provided, the past experiences are adopted as rules. In contrast to the approach adopted by engineering disciplines, only exact solutions are accepted by science, and that too when backed by rigorous proofs. So it required exact solutions, and there should be a rigorous proofs is there in case of software engineering. It means the rules can be adopted from the first experiences. So now the second issue, that it is an engineering discipline. While designing a system, there may be several conflicts goals might have, and this conflict situations can be arise when a software developer developing any software. So in such situations, no unique solutions may exist, and several alternate solutions may be proposed. So while selecting an appropriate solution out of several candidate solutions, various issues can be there. So like the main issues like cost, maintainability, usability, these are the main issues. So to arrive at the final solution, several iterations and backtracking may have to be performed. But on the other hand, in science, only unique solutions are possible. So, this is the thing. This is the difference between software engineering and science. So, in case of software engineering discipline, this is the third issue. A pragmatic approach is there. That means whatever the software developer is doing through the programs. So it's a pragmatic approach, and the approach should be cost effective, and this cost effective approach is adopted and economic concerns are addressed. But science normally does not concern itself with practical issues such as cost, maintainability and usability. So this is the difference. So software engineering is not a science. Science is different and software engineering is different. And the fourth issue, that is in this engineering discipline, these are based on well understood and quantitative principles. That means when a software developer wants to develop a program, they must have a proper knowledge. They should understand the whole thing at first, the whole system at first. But on the other hand, in case of art, it is often based on subjective judgment. That subjective judgment are actually based on qualitative attributes, not quantitative. So the software engineering is not an art also. In this section, we will discuss about evolution of an art into an engineering discipline. So at first, we have the art and science type of system, and gradually there is the engineering discipline come. So we should discuss here about that evolution. So actually software engineering principles have evolved over the last 60 years with contributions from numerous researchers and software professionals. And there are different contributions are there, and they contribute different things, and gradually it is evaluated through the software engineering discipline. So at first, in the early programmers used the build and fix, which is written down in the first point. Build and fix, that means exploratory style programming style. So actually this build and fix, that means exploratory style, is normally very poor quality of program, and it is quickly developed without making any specifications, any planning or any design. So it can be developed very quickly. And there are different imperfections are there into this type of programming. Different imperfections are there. Notice using this testing and checks when this program is tested, and these errors and these imperfections can be fixed. So the exploratory programming style is very informal style of program development approach. So this is the second point. That means it can be developed very quickly, and it will be when anything can be developed in a very quick way, in a very quickly manner, then it can be erroneous. So it must not be perfect. So this is a very informal style. It is not a formal style. It is very much informal style of program development approach. and there are no set of rules and recommendations are there. Every programmer actually programs develop their own style of programs, and this solely guided by their own intuitions, experience, fantasies and needs. So there is very much problematic. It will be very much problematic when they want to do in teamwork, because here this type of programming style is actually based on a single program developer according to his or her own style. So no one can be sure, no one can be a part of his or her program. So this is his own software development technique. So this exploratory style is also that is normally adapted by all students. You are the students. That means the novice programmers who don't have any exposure to software engineering. So this type of exploratory program development style, you can say that it is an art or science type of programming. Any art is mostly guided by the intuition. Here we are actually representing an evolution of pattern of technology. Actually, this is a schematic representations of this pattern of technology development. So here we can see that every technology initially starts as a form of art, and when times go on, it graduates to a craft and finally emerges as an engineering discipline. Now let us illustrate this fact using an example. Suppose consider the evolution of the iron making technology. So in the previous years, only a few people know how to make iron. Those who knew iron making kept it a closely guarded secret. This esoteric knowledge got transferred from generation to generation. And actually this is a family secret. So slowly this technology graduated from an art to a craft form, where tradesmen shared their knowledge with their apprentice, and the knowledge pool continued to grow. Much later, through a systematic organization of this knowledge and incorporation of scientific basis, modern steelmaking technology emerged. The story of the evolution of the software engineering discipline is not much different. It is like the same thing. So in the early days of programming, there were good programmers and bad programmers. So the good programmers knew certain principles or tricks that they can use when they develop their software. And over the years, all such good principles, along with research innovations, have systematically been organized into a body of knowledge that forms the discipline of software engineering. These software engineering principles are now being widely used in industries, and new principles are still continuing to emerge at a very rapid rate, making this discipline highly dynamic. So there is we can't deny the fact that adapting software engineering techniques facilitates development of high quality software in a cost effective and timely manner means that software needs to develop in a cost effective and timely way. We need to follow some proper rules and regulations. So the software engineering practices have proved that in this when there is a large software products, so through exploratory styles we can't develop it. We can develop a small program using the exploratory style, but a large program cannot be developed using a build and fix or exploratory style development. So we need the concept of software engineering. So in this curve we can see that in the x-axis we follow the time, and the y-axis we have a technology. So when the time goes, when the time increase, we can see that this art and first art, then craft. After that we reach to the engineering approach. So this engineering approach is actually, we can see that this is a systematic use of past experience and scientific basis. And rather this art and craft, this craft is an unorganized use of past experience, and in case of art this is an esoteric past experience. So this evaluation is happens. So at first there is an art, then craft, then engineering. Now we will discuss about software crisis. So at first we should know what is the present software crisis, what are its symptoms, and why this crisis is occurred, and what is the solutions of this crisis. So to understand this fact, we should follow this diagram. This is the causes of and solutions for software crisis. So actually there is a change in relative cost of hardware and software over time. This is one of the reasons of software crisis. That the expenses that organizations all around the world are incurring on software purchases as compared to those on hardware purchases. So it's have been showing a varying trend over the years. See in this figure that the software in 1960, what is the there is an increasing curve, that is the curve is increased here, that is hardware cost software, but when the time is going on, you can see the curve is decreasing. So this is very much problematic. So here these organizations are spending larger and larger portions of their budget on software as compared to the hardware. So not only are the software products turning out to be more expensive than hardware, but this also present a host of other problems to the customers. So this is the problem, and the software products are very much difficult to alter and debug and enhance. So using resource what the developer are using that non-optimally, and often fail to meet the user requirements. So these are far from being reliable, frequently crash, and are often delivered late. So among all this, the trend of increasing software cost is probably the most important symptoms to the present software crisis. Now we will discuss about different factors which is responsible to make the software crisis. So in present scenario, what is happening, that is many customers are actually spending much more on buying software than on buying hardware. If this trend continues, we might soon have a rather amusing scenario. That means when you bought any hardware product, the essential software that ran on it came free with it. But unless some sort of revolutions happens, in not very distant future, hardware prices would become insignificant compared to the software prices. When you buy any software product, the hardware on which the software runs would come free with the software. So there are different factors are there. Apparently, there are many factors. That is, at first, that is rapidly increasing problem size, lack of adequate training in software engineering techniques, increasing skills shortage, and low productivity improvements. That means the first point, that is rapid increasing problem size. That means suppose in the past the problem size is suppose the software developer is developing suppose 2009 software. But nowadays it's happening that there is a for example, we can say that there is a 10,009 software. So the problem size is increasing because the problem size is increasing. And the second point, that is lack of adequate training. The project developer don't have adequate training. They don't take much more training. So this is also the lack of their knowledge. So this is the problem of software crisis. And if the training is not sufficient, so the skill would be shortage also. So this is the shortage of skill is very much increasing nowadays. So this is another factor of software crisis. And another thing is the low productivity improvement. So productivity is not good. So low productivity improvement. So now we should know this is the software crisis, the factors of software crisis. Now you have to find out what is the remedy of this crisis. So in the present software crisis can possibly come from a spread of software engineering practices among the engineers, coupled with further advancements to the software engineering discipline itself. So this crisis can actually be overcome using a good training procedure, where the software developer needs good training, and if the training is sufficient and if the skill is increased, then the productivity should be high. So this is very important